PerformFISH has been a very ambitious project in so many ways. The overall goal has been the improvement of the technical performance of the Mediterranean marine fish farming. PerformFISH has pursued this goal with the ambition to help the Mediterranean marine fish farming sector step into a new era of sustainable development. Based on metrics, PerformFISH established and implemented the first ever benchmarking system based on key performance indicators. PerformFISH joined forces with 5 producers' associations to co-create and accelerate uptake by the sector. It reached out to consumers to ensure that consumer perceptions...
By public research and education institutions, small and medium enterprises, and producers' associations from Spain, France, Italy, Croatia and Greece. These producers' associations represent more than 90%.
Associations are the cornerstone of PerformFISH. They have an active role in the management of the project and decision-making. They hold the technical supervision of the project, and they validate the outputs of the project in industrial environments through the participation of 12 production companies. That their innovative benchmarking system and their revised code of conduct are major examples of the co-creative role of producers' associations in PerformFISH. PerformFISH was designed to generate impact by ensuring uptake of outputs, innovation, and new knowledge by the end users. Making the end users members of the consortium has been a strategic choice towards that direction. Young scientists have received training in the context of PerformFISH, while new research questions were formulated and got funding. After Brexit, the Mediterranean marine fish farming sector has become the top aquaculture sector in the EU in terms of value. Producing top-quality animal protein with the lowest ecological footprint, the Mediterranean marine fish farming holds a key role in food security, with high prospects to grow quickly. Consumers' expectations for convenient and nutritious food and transparent practices will build confidence in culture and enhance the image of the Mediterranean aquaculture production.
That it's the fastest growing food production sector globally, and it is generally accepted that the genetic improvement of production traits via well-designed and well-operated breeding programs has great potential. In the last 10-15 years, genomics is increasingly being applied across the broad range of aquaculture species and at all stages of the domestication. We all hope that selective breeding for genetic improvement of production traits will be able to increase this efficiency and reduce also the environmental footprint of aquaculture. We have to remember that compared to livestock, animals in which selective breeding has started a few decades back, fish are considered to be in the early stages of the domestication process. Our first objective was to apply advanced genetic approaches in an industrial context, and we delivered, collaborating with MedAid, another EU-funded project, a medium-density single nucleotide polymorphism array. This tool has already been applied in both projects, and it is expected to be used in case studies for parentage assignments and sparse genomic selection, the cross-validation of fine phenotyping in fish families, as well as the estimation. Additionally, we designed and conducted experiments for growth and mortality targeting diseases that have not previously been studied, and more specifically for the vibriosis, the monogenian Diplectanum equens, and the copypod Lernanthropus proyeri in sea bass, and the VNN in sea bream. The results are encouraging, and evaluation and validation are expected in the near future. Through this project, we confirmed that individual feed efficiency for sea bream measured in aquariums under restricted feeding is a heritable trait which could be used to improve feed efficiency in fish farming by selective breeding. Furthermore, in sea bream, body shape trajectories are proposed to be used by the industry to monitor and control fish phenotype in selective breeding programs. Last, the genetic architecture of morphological abnormality traits in gillhead sea bream were studied, contributing with new criteria into the European Certificate for Juvenile Quality. Based on
focused on the hatchery stage. So the hatchery stage is in essence at the bottom of the pyramid. It's a very important foundation because it's from here we provide the juveniles. So there was an understanding that to improve sustainability, we needed to improve the management system or a massive production of eggs and larvae. This is very different from a few small tanks in a room. And therefore, this is where work package 2 came in. We wanted a real life situation and really go into the hatcheries and work with the hatcheries, the managers, and the other people that are required in the hatchery to try and develop methods and approaches that would allow us to work across several hatcheries in different countries within Europe, so that we could look for a uniform, if possible, solution or understand what the solutions could be and if the problems were the same or different. And then the production parameters, the zootechnical parameters, how they link in potentially to the performance. Through this integration of large data sets, it was possible, therefore, to generate a program in a way that might or not be linked to traits, but that are certainly correlated or associated with the quality, so that we would generate this management tool, which would allow managers to take decisions that would be informed as to whether or not hatcheries can have a better control over what they're doing. And doing this by not looking at one individual hatchery, but looking at across hatcheries. So we're looking for transversal problems and transversal solutions. There were many challenges because, of course, production at this level is very challenging. It's a very high cost and high risk element of the production cycle, but it's been very rewarding because I do feel that we made quite significant progress.
And sort of
understood the importance of what they were doing, because everything that we do depends on what they're doing, because we get the samples from them. And if we need particular kinds of samples, it was important that they would acknowledge that's important, why it's important. The thing about science is most of us, although we're now in the era of open access and open data and so on, the reality is, there's an awful lot of data sitting in drawers because things like photographs or things that they may not have looked so good, they might not be the perfect one. So this project, and that this would help them, because we would try therefore to synthesize, in the case of malformations, what were the malformations, what do they look like, how do we look at them, and how they could be looked at by a trained. Try and also leave something that comes from this investment, both of money from the EU, from many, many people, from PhDs, try and take from that and leave a document which is comprehensive and that is covering how to sample. And this
are really essential for the responsibility and sustainability of the marine farming sector. Not only from the economic point of view, but also from the social and environmental points of view. Benefits of the activity should be seen in an integrated focus on this, because all of them are interconnected. Economy as a single element does not justify anything. All these aspects matters and should be addressed following intelligent, integrative, holistic, and win-win research and activities in Work Package 3 have been designed from the very beginning from the farmer's perspective. And also these activities has been developed together, hand in hand with farmers and with all the stakeholders involved in this sector. So in fact, Work Package 3, as well as the other PerformFISH work packages, is for the Mediterranean fish farmers and with the Mediterranean fish advancements in diagnostics, management, prevention, and fish welfare. We really did not want to reinvent the wheel. We really wanted to innovate in the aspects or gears that were necessary and also deliver to the industry improved guidelines as something like gearboxes to boost the efficiency of the systems in all the aspects related to disease control, health, and welfare.
is defining optimal levels for micronutrients. So these are mineral and vitamins, basically. And it's very interesting to see that despite being one of the most important fish that's produced in the EU, within the EU, there hasn't been much attention focused on mineral and vitamin requirements for Gillette sea bream. And actually, there was almost no knowledge behind the requirements of this for these fish. And they are essential, right? So we need to include them in the diet. They cannot produce them. They cannot synthesize them in the novel. And during this this project, we have managed to define optimum levels for 3 minerals and for 6 vitamins. So this is like a major breakthrough. And as I say, one small change in the amount of any of these micronutrients can go a long way in terms of efficiency. We can see a higher growth. We can see a lower prevalence of diseases, of skeletal anomalies, byproducts from the poultry industry. So we've been using poultry oil, for example, and we've been using also ingredients from marine origin, but farmed marine origin. For example, microalgae, which is the great one of the greatest assets that we have if we want to cultivate the sea, right? If we can substitute 100% of the fish oil from feeds in Gillette sea bream with this blend of poultry oil and microalgae oil derived from a commercially available source, and we did see there were no differences. 6% of this fish meal with insect meals and single cell proteins, which are derived from yeast or from bacteria cultures. And as the same case as with the oils, we have seen that there's no differences in growth and there's no differences in other productive parameters. So basically, we call it nutritional programming, which is a way of changing in certain key aspects of the developmental stages of the fish. So broodstock, what we're doing is that we're putting this environmental input, which causes a series of epigenetic changes in the fish, and then they are able to use better, which is a series of resources. Basically, a tool in which you can compare the conditions in which your fish are being reared, densities, temperature, but especially nutrition-wise, and you can see what are your conditions in your farm, what are your feeds, what's the nutritional profile of your feeds, and you can compare it with the levels that we have been describing in the project.
There is the ever ongoing question about freshness. Is the fish actually caught the day it's caught? Is it slaughtered the day it's taken from the aquaculture site? That is one thing. In some countries, there has been some fraud as for the species that how much of a CO2 footprint, if you like, does this fish represent? There's been some issues with the Norwegian salmon, etc. We all know that. Questions and analysis that we did showed that there was a big difference between the countries. The consumer perception of the species, how much a tradition the species was or not a tradition. It could be the US market that the Italian people was very happy about. There is, of course, the case about freshness, and you need to transport these fish. Consumers, are they reluctant or not to get a fish which is fresh, hasn't been frozen, and it's been underway for quite some time, exploring the markets and the possibilities of these two fish in different markets, old markets and novel. It's completely new. I don't think we should hide the species, but perhaps one should think about that one should not be seeing the whole fish to begin with. It could be a more exclusive thing, even though people will be paying for the head, the bones, etc., higher kilo price.
In case of sea bass and sea bream aquaculture, we know that the sector contributes significantly to wealth and job creation in rural and coastal areas in at least 10 different Mediterranean countries. However, there's a lack of sector data. Information available, for example, on production data, fish input, harvest, sale, production losses at farm level, PerformFISH project to develop an appropriate data recording system and tools that can help the monitoring of the input and the output at farm level and facilitate the analysis maker. This is really in line with the new common fishery policy, with the Blue Grow agenda and the Farm to Fork strategy for the achievement of sustainable development goals. PerformFISH has developed a benchmarking system that is based on key performance indicators to monitor and benchmark the biological capacity, cost efficiency, and fish health and welfare. And also, the key point of this system are specifically two. The first one is that the system was designed for sea bass and sea bream aquaculture and for being applied to the whole production cycle from hatchery to grow out till harvest, excluding the processing chain. The first one is an interactive and user-friendly interface to support and facilitate farmers for online collection of production data. The KPI system can help different categories of stakeholders. First, the farm manager to benchmark production performance at farm level. Then the company manager to compare the performance across different farming sites. The producer association to establish it, but also other different categories of aquaculture could take advantage from the use of the KPI system, such as regulators and policymakers at European. I hope that the code of conduct is to serve the vision of sustainability of Mediterranean marine fish farming sector, and to promote proper and responsible practices and to safeguard the quality along the production line. And let's say that for the first time the implementation of the code of conduct will be supported by key performance indicators. And this is a code of conduct and harmonized standards based on robust indicators can for sure facilitate trade and also strengthen a common vision for a sector of common sea, the Mediterranean, common practices, and common contribution to sustainable blue economy.